Good morning, guys. So I know that we had some issues with ClassLink, but hopefully it's up and working for you correctly now. And I am so excited because this week we are starting our informational essays, and we are going to be using the texts about rocks that we read last week and the week before. Now, if you haven't read them yet, that's okay, because we're going to read them together, and we are going to highlight important information and talk about the main idea of each paragraph so that you can use these resources to write an amazing informational essay. Okay, so the first one we're going to start with is the igneous rocks passage. So hopefully you have this printed in front of you with a highlighter and a pencil so that you can highlight and annotate along with me, which will make your life much, much easier when it comes time to plan your essay. So here we go. Passage 1, Igneous Rocks by Leah Lott. Magma and lava. To understand how igneous rocks are formed, we need to understand magma and lava. It might seem impossible, but rocks can melt into a liquid. Ooh, I think that's important. I'm going to go ahead and highlight that. Rocks can melt into a liquid. And this liquid is called magma or lava, depending on where it is. If the melted rock is below the Earth's surface, we call it magma. Okay, they just gave us the definition of magma. I'm going to box in the word magma. And right before it, it told us that if it is below the Earth's surface, we call it magma. If the melted rock is above the Earth's surface, we call it lava. All right, so we're going to box in the word lava. Above the Earth's surface, we call it lava. Igneous rocks form when magma or lava cools. That is why igneous rocks are often called volcanic rocks. All right, so we don't even have to mark the main idea of this passage because it's right here in the heading, magma and lava. That's what that was all about. And then they give us a nice visual. Okay, so when it's melted down here below the Earth's surface, it's magma. And when it's coming up out of the volcano and it's above Earth's surface, it's lava. All right, so you should have the same things highlighted, boxed in, and underlined as I do. I'm going to go ahead and clear this so I can move on to the next page. All right, intrusive and extrusive. There are two types of igneous rocks, intrusive and extrusive. Okay, let's go ahead and highlight that. That's important. It's telling us that there are two types of igneous rocks, intrusive and extrusive. Intrusive igneous rocks form when magma cools underneath the Earth's crust. And extrusive igneous rocks form when lava cools above the Earth's crust. All right. They give us the definition of both of those terms. Okay, we know that we have intrusive igneous, and they form when magma cools. And we know that magma is underneath the Earth's crust. And then extrusive igneous rocks form when lava cools. And we know that lava is above the Earth's crust. And then again, they give us a nice visual. So if it cools underneath, it's intrusive. It's inside the Earth still. Okay, look at those prefixes to help you. Intrusive, inside. Extrusive is when lava cools, and that's outside of the Earth, above the Earth's crust. Think about when you exit, okay? That EX prefix can help you remember that intrusive is underneath and extrusive is above. Intrusive igneous rocks take a lot longer to cool than extrusive igneous rocks. As the magma slowly cools beneath the Earth's crust, coarse grains and large crystals form. The longer the magma takes to cool, the bigger the crystals get. Diorite, gabbro, and granite are examples of intrusive igneous rocks. Slabs of granite are often used for countertops. This is because granite is hard to scratch and low maintenance. The most important part of this, boys and girls, is this right here. The longer the magma takes to cool, the bigger the crystals get. That's how those large crystals inside of the rocks form. All right, I'm going to pause for a moment so that you can make sure you have the same things highlighted, boxed in, and underlined as I do. All right, I'm going to go ahead and clear everything so that I can move on to the next page. Remember, you can always pause this video and back it up and go to an earlier point in it if you need to. Ooh, foot. Extrusive igneous rocks form when magma makes its way to Earth's surface. The melted rock erupts or flows as lava and then cools quickly, forming rock. What these rocks look like after they cool will depend on the minerals that are inside of them and how quickly they cool. Extrusive rocks have fine grains and little to no crystals. All right, so this one is all about the extrusive igneous rocks. They tell us how they form, okay? It cools quickly. And they also tell us what they look like. So what they look like depends on the minerals and how quickly they cool. They also tell us that they have little to no crystals. So extrusive igneous rocks cool quickly, and how they look will depend on the minerals and how quickly they cool. But we do know that they will have little to no crystals. Paragraph 5. Some extrusive igneous rocks cool with gas trapped in them. After they solidify, the gas escapes, leaving air pockets. Pumice and scoria are examples of extrusive igneous rocks that have air pockets. Pumice is a very unique rock. It is lightweight and is known for being the only rock that can float in water. And they give us a visual. This person is scrubbing their foot with a pumice stone. And you might have pumice in the bathroom. Pumice has a coarse texture, so it is often used to scrub the calluses off of people's feet. So how is that formed? How does it get those little holes inside of it? That's what this paragraph was mostly about. Some extrusive, we're still talking about extrusive rocks. When they cool with gas trapped inside of them. Gas trapped in them. Then the gas escapes, leaving air pockets. And then they give us 2 examples of this type of rock. Paragraph 6. Another igneous rock is obsidian. Obsidian is an extrusive rock that forms when lava cools rapidly, preventing crystals and air pockets from forming. It is often called nature's glass because of its glass-like appearance. Obsidian is easy to identify due to its dark color, usually black but sometimes green. Sharp edges and conchoidal fractures, meaning it breaks into C shapes. People use obsidian for jewelry and decorative pieces. Some surgeons use it in the hospital because it is thinner and sharper than many modern tools. Obsidian was a very useful tool in the Stone Age because it could be chipped to make knives, arrowheads, spear points, and many other weapons and tools. So this time, we're still talking about extrusive igneous rocks, okay? It told us that right here. We're still talking about extrusive. But this whole paragraph is about a very specific type of rock. This whole paragraph is about obsidian. It tells us that it cools rapidly. It gives us another name for it, nature's glass. It tells us that it's dark in color. It has sharp edges. And it gives us this very interesting vocabulary word. Even I had a hard time pronouncing it. I'm going to highlight that in green. Conchoidal. I think that's how you say that. And if we have a hard time remembering that word, we can look in the parentheses. It tells us the definition of that word in the parentheses here. It means that it breaks into C shapes. So when you break it, the edges will form these C shapes. See right here, there's 1, there's 2, there's 3, there's 4. Here's like a big one right here. Here's another one. So I highlighted those fractures in green for you to match the green up here, okay? This right down here, I highlighted it in green so that you can really see what it means to have conchoidal fractures, meaning it breaks into C shapes. And then it tells us some uses for obsidian. We're just going to box in people use obsidian. Okay, so it tells us how it's formed, another name for it, what it looks like, and what people use it for. All right, so you should have the same things boxed in, highlighted, and or underlined as I do. And if you need to pause it, then feel free. All right, last page of this one. The most common rock on Earth is basalt. Okay, that is like a main idea right there. The most common rock on Earth is basalt. And I'm going to go ahead and box in the name of that word, or of that rock, basalt, which is another extrusive igneous rock. So we're still talking about extrusive. Basalt is commonly found underwater. In fact, most of the ocean floor is basalt. That's a fun fact. Most of the ocean floor is basalt. You might be thinking, If basalt is magma that has cooled, then that means that magma must have been underwater. How did magma get underwater? It's because there are many volcanoes underwater. Volcanoes don't just erupt through the continental crust. Many volcanoes occur on the oceanic crust, especially around the Ring of Fire. When Earth's tectonic plates move away from each other, or divergent plate boundaries, the magma comes up into the ocean, cools quickly, and forms new seafloor crust. It's kind of like when you get a scrape on your knee. The blood is like the magma. When it heals and scabs, it's kind of like the new seafloor crust. All right, so this whole paragraph was about basalt and that it's underwater and most of the ocean floor is made out of it. Then they tell us why that happens. It's because there are many volcanoes underwater. They tell us about the Ring of Fire, which is where many of the volcanoes are that are on the oceanic crust of the Earth. They talk to us about tectonic plates, and that when they move away from each other, that's called divergent plate boundaries. Okay, when they're moving away from each other, that is divergent. Paragraph 8, igneous rock characteristics. If you look at various igneous rocks, such as granite, pumice, and obsidian, it's easy to see that igneous rocks have many different characteristics. If they are intrusive, then they will most likely have large crystals. If they are extrusive, they might have air pockets or look like glass. But whether they are intrusive or extrusive, there is one characteristic that all igneous rocks share. I'm going to go ahead and highlight that. That is important for us. There is one characteristic that all igneous rocks share. Can you think of what it is? What do all igneous rocks have in common? The answer has to do with layers. Every single igneous rock doesn't have layers. So next time you find a rock that has large crystals, air pockets, a glassy texture, or doesn't have any layers, then it is probably igneous. So this paragraph told us what igneous rocks have in common and how they're different. Let's see right here. Every single igneous rock doesn't have layers. They have no layers, 0 layers. They can have air pockets and they can look like glass, but they will not have layers. All right, and then at the bottom of this, it gives you a glossary with 1, 2, 3, 4, 5 vocabulary words. So if while you're planning your essay, you're confused about a word, you can always look at the glossaries at the bottom of the articles. All right, so that was igneous rocks. And next we will move on to sedimentary rocks. I'm going to post that in another video so that it's not too much at one time. All right, guys, I will see you in a little while.